Namaste to all. Today I have come with a video of trigonometry applications of heights and distances. So let us learn about the uses of trigonometry. Trigonometry is a vast language and it is used in various aspects of life. It is used in order to know the various heights and distances of various objects, like an underwater submarine, the height of the sea, and many more. So, in order to know the various applications of trigonometry, we should first know about two basic angles. One is the angle of elevation, another one is the angle of depression. The angle of elevation is the angle which is between the line of sight and a horizontal, which is generally the ground when we are looking up. On the exact opposite, the angle of depression is a line of sight that we look downwards and the horizontal. So both the two angles are opposite of each other. These two angles are important in solving trigonometric applications. So here is a basic idea of what the angle of elevation and the angle of depression is. So, before going further, let us revise our concept of a right angle triangle. In a right angle triangle, the perpendicular or the vertical is known as the opposite side, the horizontal is known as the adjacent side, and the side opposite to the 90-degree angle is the hypotenuse. Generally, an angle between of B and C as shown in the figure can be represented by theta. So, in earlier class, we got about the six ratios of trigonometry, which were sine theta, cos theta, sec theta, cosec theta, and tan theta and cot theta. Now, these are known as the reciprocal identities because one is the reciprocal of another. Sine theta is the reciprocal of cosec theta or vice versa. Similarly, cos theta is the reciprocal of sec theta or vice versa, and tan theta is the reciprocal of cot theta or vice versa. The next type of identities we got were the quotient identities. The quotient identities were tan theta is equal to sine theta by cos theta and its opposite, that is cot theta, is equal to cos theta by sine theta. The next type of identities we got were the Pythagorean identities, which were sine square theta plus cos square theta is equal to 1 plus tan square theta is equal to sec square theta, and 1 plus cot square theta is equal to cosec square theta. These are known as Pythagorean identities because they are generally derived from the Pythagoras theorem. So, in the earlier class, we also got the specific values of some of the specific angles of the six trigonometric ratios, like sine 0 degree is equal to 0, cos 0 degree is equal to 1, cos 30 degree is equal to root 3 by 2, and many more. So, the next topic we earlier got were the complementary angles. That is, sine theta is equal to cos 90 degree minus theta, cos theta is equal to sine 90 degree minus theta, tan theta is equal to cot 90 degree minus theta, cot theta is equal to tan 90 degree minus theta, sec theta is equal to cosec 90 degree minus theta, and cosec theta is equal to sec 90 degree minus theta. So let us see our first question. Two ships are sailing in the sea on the two sides of a lighthouse. The angle of elevation on the top of the lighthouse is observed from the ships at 30 degree and 45 degree respectively. If the lighthouse is 100 meter high, the distance between the ships is 173 meter, 200 meter, 273 meter, 300 meter. So now I have represented this question in a form of a triangle. Here AB is the lighthouse and B2 is the distance from the lighthouse to a ship, and B1 is a distance from another ship to the lighthouse. Now the angle is given to be 45 degree and 30 degree. We have to find B1 plus B2. So here we take tan theta. We take tan theta because it is equal to perpendicular by base, and since the perpendicular is provided and the base is needed to be found, so we take tan theta. Here tan 30 degree is equal to 100 by b1, and from here we can get by 1 by root 3 is equal to 100 by b1, since tan 30 degree is equal to 1 by root 3. So now by cross multiplication method we get b1 is equal to 100 root 3 meter. Then we take tan 45 degree is equal to 100 by b2. Since in the case of tan 45 degree we get perpendicular as 100 and b2 as the base. We know that tan 45 degree is equal to 1, so we get 1 is equal to 100 by b2, and by cross multiplication we get b2 is equal to 100 meter. So we got the value of b1 as 100 root 3 and the value of b2 as 100. So the distance between the two shapes will be b1 plus b2, that is 100 root 3 plus 100 is equal to 273 approximately. So the answer is 273. So the next question is, the angle of elevation of a ladder leaning against a wall is 60 degree and the foot of the ladder is 4.6 meter away from the wall. The length of the ladder is, the options are 2.3 meter, B 4.6 meter, C 7.8 meter, and D 9.2 meter. Now this question is very easy, so let us try to solve it. So here we can see ABC is a triangle where AB is the wall and AC is the ladder tilted towards the wall with an angle of elevation of 60 degree. Given that BC is equal to 4.6 meter, we have to find the length of the ladder or AC. So, in this question, since the base is given and we have to find the hypotenuse, so we take cos theta. Here, cos 60 degree is equal to BC by AC. We know the value of cos 60 degree, which is half. We get half is equal to 4.6 divided by AC, and then by cross multiplication, we get AC is equal to 9.2 meter. So, the answer is 9.2 meter. So the next question is, an observer 1.6 meter tall is 20 to 3 meter away from the tower. The angle of elevation from his eye to the top of the tower is 30 degree. The height of the tower is, so here the various options are A 21.6 meter, B 23.2 meter, C 24.72 meter, and D none of these. So here let us consider AB as the observer, who is 1.6 meter tall, and EDC as the tower. It is given that the distance between B and C here is 20 to 3 meter. We will also see that there is a point D in such a way that AB is equal to DC. So here we will find that this type of figure is a trapezium. So in order to solve this problem, we have to draw a line AD which is parallel to BC. It is also given that the angle of elevation from his side to the top of the tower is 30 degree. So here, considering AD as the horizontal, we get that angle EAD is equal to 30 degree. So here we'll see that triangle AED is an right angle triangle. So here we can see that ABCD is a rectangle. So therefore the value of AB is the same as the value of CD, or vice versa. So here the value of AB is given to be 1.6 meter. So the value of CD is equal to 1.6 meter. Similarly, we will see that BC is equal to AD. That is, since BC is equal to 20 root 3 meter, so therefore AD is equal to 20 root 3 meter. So therefore, in triangle AED, we got that AD is equal to 20 root 3 meter and angle EAD is equal to 30 degree. In order to find the height of the tower, we need to find ED. Since we have the base and we need to find the perpendicular, so we take tan 30 degree is equal to ED by AD. We get 1 by root 3 is equal to ED by 20 root 3, and from this we get ED is equal to 20 meter. So from here we get the height of the tower as ED plus CD, that is 20 meter plus 1.6 meter, we get the answer to be 21.6 meter. So here we get the angle of elevation of the sun when the length of the shadow of a tree root 3 times the height of the tree is option A 30 degree, option B 45 degree, option C 60 degree, and option D 90 degree. So here we have drawn a figure to demonstrate this question. Here AB is the height of the tree and BC is the length of the shadow. We must find the angle BAC because it is the angle of elevation of the sun. So this question is very easy. Let us try to solve it. Here it is given the base as root 3 times, that is the length of the shadow is given to be root 3 times the height of the tree. So since we have taking the height as A and the shadow, that is the base, as root 3A, we get tan theta is equal to BC by AB. The BC here is root 3A and a base here, that is AB, is A. So taking tan theta is equal to root 3 by A, we get tan theta is equal to root 3. We know that tan 60 degree is root 3. Also, we have found that tan theta is equal to root 3. So from here we get that tan theta is equal to tan 60 degree, and from here we get that theta is equal to 60 degree. So the correct answer is 60 degree. So, in this question, we can see that a poster is on top of a building. Rajesh is standing on the ground at a distance of 50 meters from the building. The angles of elevation to the top of the poster and bottom of the poster are 45 degree and 30 degree respectively. What is the height of the poster? The various options are 50 root 3 minus 1 by root 3 meter, or 50 root 3 meter, or 25 by root 3 meter, or none of these. So here Rajesh is standing at position C and the building is DB and the poster which is present is at a height of AD. We have to find the height of the poster, where it is given that angle BCD is 30 degree and angle BCA is 45 degree. So let's solve the question. So here we can see that BC is 50 meter, since it is given that the distance between the base of the building and Rajesh is 50 meter. So here by taking tan 30 degree we get BD by BC, and from here we get 1 by root 3 is equal to BD by 50 meter, since the value of BC is 50 meter. So by cross multiplication we get BD is equal to 50 by root 3 meter. Moving next, we get tan 45 degree is equal to AB by BC. So from here we get 1 is equal to AB by 50 and then AB is equal to 50 meter. We know that the height of the poster is AD, so therefore by subtracting BD from AB we get 50 minus 50 by root 3, that is 50 root 3 minus 1 by root 3 by taking the LCM. So therefore the true answer is A. So the next question is, a tree is cut partially and made to fall on the ground. The tree, however, does not fall completely when it is attached to its cut part. The tree top touches the ground at a point 10 meters from the foot of the tree, making an angle of 30 degree. What is the length of the tree? The various options are 10 root 3 meter, 10 by root 3 meter, root 2 minus 1 by 10 meter, and 10 by root 2 meter. So let us try to solve this problem. So here the tree is actually BC. However, it is given that the tree was cut at a point A. So therefore, we form a triangle here, that is triangle ABC. It is also given that the distance between the foot of the tree and the point where the tree top reaches the ground is 10 meter and the angle of elevation is 30 degree. So here we have to find the length of the tree, that is BC. If we can find AB and AC, then we can easily find BC. So now taking tan 30 degree is equal to AB by BC, we get 1 by root 3 is equal to AB by 10 meter, and then we get AB is equal to 10 by root 3 meter by cross multiplication. Next, by taking cos 30 degree is equal to BC by AC, we get root 3 by 2 is equal to 10 by AC, and then AC is equal to 20 by root 3 meter. Since the height of the tree is AC plus AB, we get AC plus AB as 20 root 3 plus 10 root 3, and then we get 30 by root 3 meter. Now we try to rationalize 30 by root 3 meter, and then we get 30 by root 3 meter as 30 root 3 by 3 meter, and then we get 10 by root 3 meter. So the correct answer is A, that is 10 by root 3 meter. So that's the end of my video for today. Please subscribe it, and if you like it, and please share it. Stay home, stay safe.